Good morning everyone, and welcome. Today, we're diving into the exciting world of payment fraud detection and exploring how machine learning is transforming this critical area. Our presentation is titled, Advancing Payment Fraud Detection with Machine Learning, and we'll be focusing on how modern techniques can enhance accuracy, enable real-time responses, and improve adaptability. I'm looking forward to sharing insights and innovations that are shaping the future of secure payments. Let's get started. Payment fraud refers to unauthorized or deceptive financial transactions that lead to substantial economic losses. Traditional systems, which rely mainly on fixed rules, often can't keep up with the constantly evolving tactics that fraudsters use. This is where machine learning comes in. By analyzing large amounts of data automatically, machine learning can identify suspicious patterns and stop fraudulent payments almost in real time. It learns from past transactions, getting better at detecting fraud and responding more quickly. Compared to conventional methods, machine learning offers a much more effective way to prevent and manage payment fraud. When we talk about fraud detection in machine learning, there are a few key concepts to understand. First is classification, which is all about sorting transactions into categories, either fraudulent or legitimate. This helps us quickly flag anything suspicious. Then, there's anomaly detection, which focuses on spotting unusual patterns that don't fit the normal transaction behavior. These anomalies can often be red flags for fraud. Next, we have features, which are the various pieces of information we use as inputs. This can include things like the transaction amount, merchant details, or location, all of which give crucial context to the data. Lastly, models are the algorithms we train to do the heavy lifting, things like decision trees or neural networks that learn from these features and help us predict whether a transaction is likely fraudulent. Together, these concepts work to create a robust fraud detection system. When it comes to detecting fraud, the data we use is absolutely crucial. First, we look at transaction data, which includes details like the amount involved, the exact time and location of the transaction, and information about the merchant. These attributes help us spot anything unusual that deviates from normal patterns. Next, we consider user behavior data, such as login patterns, the types of devices being used, and the user's typical activity history. This helps us understand what's normal for each individual, making it easier to detect suspicious changes. Finally, historical fraud labels play a key role. These are confirmed cases of fraud that we use to train our models through supervised learning. By combining these sources, we extract key features that capture both behavioral and transactional subtleties, enabling our machine learning models to recognize patterns indicative of fraudulent activity. When it comes to detecting fraud, there are several machine learning techniques that are commonly used. First, we have supervised learning. This method relies on labeled transaction data, meaning we already know which transactions are fraudulent and which are legitimate. Using this information, the model is trained to classify new transactions accurately. Then there's unsupervised learning, which is different because it doesn't require labeled data. Instead, it looks for anomalies or unusual patterns by grouping similar transactions together and identifying those that stand out from the rest. Another effective strategy is hybrid approaches. These combine the strengths of both supervised and unsupervised learning, making use of both labeled and unlabeled data to enhance detection performance. Lastly, continuous adaptation is crucial. Fraud tactics evolve constantly, so these models need to keep learning from new data to stay effective and catch emerging fraud schemes quickly. This ongoing learning process makes the systems adaptable and resilient over time. First, we start with data collection, where we gather transaction details and user behavior information. This provides the foundation for everything that follows. Next, we move to data pre-processing, which involves cleaning the raw data and extracting features that are most relevant to identifying fraud. Then, we use this prepared data to train our machine learning models, relying on historical, labeled examples to help the model learn what fraudulent activity looks like. Once the model is trained, we implement real-time scoring to quickly evaluate new transactions as they occur, allowing us to catch suspicious behavior immediately. Finally, when the system detects something potentially fraudulent, it generates alerts so that either automated systems can block the transaction or human analysts can review it further, helping to prevent fraud before it causes harm. One of the major challenges we face in using machine learning for fraud detection is concept drift. Fraudsters constantly change their tactics, which means our models need to be updated regularly to keep up and stay accurate. Another significant issue is class imbalance. Since most transactions are legitimate, fraud cases are extremely rare, making it difficult for the model to identify those few fraudulent activities effectively. We also have to contend with false positives. When legitimate transactions are incorrectly flagged as fraud, it can frustrate customers and erode their trust in the system. Lastly, data privacy is a critical concern. We must ensure that sensitive financial information is protected at all times, even while we use this data to train models and detect suspicious behavior. Balancing these challenges is key to building an effective and reliable fraud detection system. When we look at the benefits of using machine learning in payment fraud detection, the first major advantage is improved accuracy. Machine learning models can uncover intricate and subtle fraud patterns that traditional rule-based systems often miss. This means they're much better at catching fraudulent activity before it causes damage. Next, we have real-time detection. With machine learning, suspicious transactions can be identified and acted upon instantly. This immediate response is crucial in preventing fraud from progressing further. Another key benefit is adaptive learning. Machine learning models aren't static, they continuously learn and evolve as new fraud tactics emerge. This adaptability keeps the system effective even as fraudsters develop more sophisticated methods. Finally, there's a significant reduction in manual review. By automating much of the detection process, companies can cut operational costs and speed up decision-making, allowing human experts to focus on the most complex cases. Together, these benefits make machine learning a powerful tool in the fight against payment fraud. As we look to the future of payment fraud detection, machine learning remains the foundation. It provides us with greater accuracy, real-time detection capabilities, and the flexibility to keep up with new and evolving threats. Beyond that, deep learning and graph-based models are becoming essential tools, allowing us to recognize more complex patterns that traditional methods might miss. Another critical advancement is the use of biometric and multi-factor authentication, which significantly enhances how we verify identities and protect user accounts. Lastly, preserving user privacy is paramount, so privacy-preserving machine learning techniques like federated learning are gaining traction. These methods enable us to train models effectively while safeguarding sensitive user data throughout the process. Together, these directions represent the cutting edge of securing payment systems against fraud.